students, I think you have understand the last day's topics which I have already discussed on the basicity of amines in part 1. Now today I will finish the rest of the topics in part 2. Please try to understand, okay? Now last day I have already discussed that alkyl group has electron donating groups. So if any electron donating group is present in amine, they donate electrons. Already nitrogen has a lone pair of electron. Actually it's a cloud-like representation. So whenever this alkyl group donates electrons towards the nitrogen, then see the volume of the lone pair of electron, the density of the lone pair of electron increases. So presence of electron donating group increases the density of lone pair of electron, increases the density of lone pair of electron. So remember it, when any electron donating groups, alkyl group have electron donating nature, alkoxy group, methoxy, ethoxy have electron donating natures. When any electron donating group is present, then the density of lone pair of electron on nitrogen increases. Thus protonation, this is called addition of proton, is called protonation. Thus protonation, addition of proton is called protonation, becomes easier. Protonation becomes easier. So increases the density of lone pair of electron due to the presence of electron donating group, increases the basicity. So basicity increases, which I have discussed in the last topics clearly. It's a revision. When any electron withdrawing group, aryl or phenyl, benzene, whenever attached to anything called aryl or phenyl, is attached to the nitrogen of amino group, then see, benzene attracts electron cloud. That's why the density of lone pair of electron on nitrogen decreases. The density of lone pair of electron on nitrogen decreases. So the density decreases. Density of lone pair of electron on nitrogen decreases. That's why basicity decreases. This I have already covered in the last topics. I think you have go through it. So listen. Now two basic compounds are there. Both are basic in nature. Maybe aliphatic, maybe aromatic. Question is that how do we know which compound is more basic, which compound is less basic? That is, numerically we can calculate the extent of basicity. Numerically we can calculate the extent of basicity. Let's check. So remember it, electron donating group increases the basicity and electron withdrawing group decreases the basicity. We can measure the extent of basicity on the basis of dissociation constant of base. Now see, we can measure the extent of basicity or the strength of basicity, okay, extent or strength of basicity in terms of dissociation constant of the base. Dissociation constant of base denoted by Kb. So remember it, we can determine the strength of basicity on the basis of dissociation constant of base, that is Kb. What is Kb? Say it's a base, BOH, it's a base. When it breaks, B possesses positive charge and OH possesses negative charge. This is hydroxyl group. So base releases hydroxyl group. As it is in equilibrium, so according to the concept of equilibrium, it's in your class 11 actually. So the dissociation constant of base, the dissociation constant of base, that is Kb, we can write Kb equals to concentration of product by concentration of the reactant. So see here, OH in upside, Kb is also in upper side, below it's 1. So we can say directly, greater the value of Kb, more will be the OH. That's why basicity increases. So the basicity of a compound can be measured in terms of dissociation constant. So you can say Kb is directly proportional to basicity. Greater the value of Kb, more will be the basicity. Greater the value of Kb, more will be the basicity. More will be the basicity. Understand? Reverse of Kb is called Pkb. Now write it, okay? Write it. Now remember it, the reverse of Kb is called Pkb. The reverse of Kb is called Pkb. The reciprocal of Kb is called Pkb. The reciprocal of Kb is called Pkb. Obviously, if Kb increases, basicity increases. So if Pkb increases, basicity decreases. Okay, that is Pkb is reciprocal of Kb. So you can say that Pkb is inversely proportional. So if Pkb increases, basicity decreases. So you can say if Pkb increases, basicity decreases. If Pkb increases, basicity decreases. So understand it. If Kb increases, basicity increases. If Pkb increases, basicity decreases. Now, questions on the basis of Pkb, okay? Understand the question. Aniline has more Pkb value. It is a numerical concept. Pkb value than ethyl amine. Why? Aniline has more Pkb value than ethyl amine. Pkb value becomes more, means that aniline is less basic than ethyl amine. Once again, if Pkb value becomes more, it indicates that aniline is less basic than ethyl amine. So, in the question, it is clear that as Pkb of aniline is greater, so it is less basic than ethyl amine. What is the reason? Just draw the structure of aniline. Benzene, you can draw benzene in flat way, okay? Benzene, NH2, nitrogen has lone pair. You know that benzene has electron withdrawing nature due to resonance, electron withdrawing nature. And in ethyl amine, C2H5, NH2. You know that ethyl group has electron donating nature. So this is electron donating group and it is electron withdrawing group, and you know that presence of electron withdrawing group decreases the basicity. That's why aniline is less basic. That's why the Pkb value of aniline is more. Okay, that's why the Pkb value of aniline is more. Now, next question. Always remember it. Presence of electron donating group increases the basicity. Presence of electron withdrawing group decreases the basicity. Now, question. Which has lesser Pkb value? Which has lesser Pkb value? Remember it. Lesser Pkb value. Aniline or cyclohexyl amine. Can you tell me which has lesser Pkb value? Lesser Pkb means more basic. Now, answer. From the question, it's clear that lesser Pkb means more basic. So, lesser Pkb means more basic. Clear? Lesser Pkb means more basic. Draw the structure. Always draw the structure. Okay? Always draw the structure. Aniline. Nitrogen has lone pair of electron. Nitrogen has 5 valence electrons. 3 are engaged in formation of bonding 1 and 2, 3. So remaining 2. The non-bonding electrons are called lone pair of electrons. This is aniline. Okay. Always write the name aniline. And how to draw cyclohexyl amine? Very easy to draw cyclohexyl amine. Just remove the ring. Inside the benzene, the ring, just remove, it becomes cyclohexyl amine. Remember it, if any compound contains YL, it's aliphatic, alkyl nature. So, as you know that benzene has electron donating natures, so it has electron donating nature. And any alkyl group, you know that I have already discussed, any alkyl group has electron donating nature. This is an electron withdrawing nature. Electron withdrawing group benzene has, and it has electron donating group. Electron donating group. So presence of electron donating group increases the basicity. So it is more basic. So it is more basic. So obviously it is less basic. Now see the question. pKb value, lesser pK value means more basic. So cyclohexylamine is more basic. Cyclohexylamine is more basic. So we can write, this is cyclohexylamine. Cyclo, methyl, ethyl, propyl, butyl, pentyl, hexyl. Cyclohexylamine is more basic. More basic means less pKb. Clear? More basic means less pKb. Clear? So as cyclohexylamine is more basic, so it has lesser pKb. So what is the conclusion? As cyclohexylamine is more basic, so it has lesser pKb value. Understand? Very easy. Presence of electron donating group increases the basicity. Presence of electron withdrawing group decreases the basicity. That's much. Now the next question. I think you understand. Now next, see the another question. This is a compound NH2. Don't write, okay? Don't write NH2. Can you tell me what is its name? Hydrazine. Okay? It's a good reducing agent. Actually, it is also used as propellant in rocket. Remember it. It's a reducing agent also. It's a good reducing agent. Hydrazine. It's a hydrazine. When you remove one hydrogen by amide group. See, don't write amide group. How to know amide group? Listen now. This is carboxylic acid. You know that this is carboxylic acid group. Whenever you replace the OH group of carboxylic acid by NH2 group, it's called amide. So in place of one hydrogen of hydrazine, write one amide group. And can you tell me what is its name now? You have seen in nucleophilic addition reaction in aldehyde and ketone chapter, that is the reactivity of aldehydes and ketones. Just tell me. Yes, it is semi-carbazide. It's semi-carbazide, okay? It's semi-carbazide. You know that nitrogen has lone pair of electron. Now draw the lone pair of electrons on nitrogen. Now say this nitrogen is numbered as 1, this nitrogen is numbered as 2, this nitrogen is numbered as 3. So just arrange the nitrogens in decreasing order of basicity. Arrange the nitrogens in decreasing order of basicity. Okay, and is the nitrogen in decreasing order of basicity. This is semi-carbazide, ZID, okay. Now, can you tell me which nitrogen is the most basic? This or this? Listen, if we consider this nitrogen atom is attached to the carbonyl group. As the carbonyl group contains pi bond, double or triple bond called pi bond. Pi bonds. So this part undergoes resonance. How? The oxygen atom, due to more electronegativity than carbon, oxygen attracts one pi bond. As soon as oxygen attracts one pi bond, then what happens? Resonance takes place. So NH2 remains as same. NH, this is 1, this is 2, and this part O negative, NH2, and this lone pair shifts here. So the nitrogen becomes positively charged. That's why you say that due to resonance in amide group, the lone pair of electron on nitrogen 3 is reduced. The density of lone pair is reduced. Similar thing is happened here also. But if we compare this and this, it also undergoes resonance. But if you compare this and this, it is directly attached to the electron withdrawing group. If any group in organic chemistry contains pi bond, double or triple bond, remember it as an electron withdrawing nature. It is also attached to electron, so it also undergoes resonance. But you know that amino group has certain extent electron donating group. Amino group has certain extent electron donating group. So presence of the electron donating amino group increases the density of lone pair of electron on nitrogen, though there is also resonance. That's why we can say that this is the highest basic because it is not attached to any electron withdrawing group. Highest basic, nitrogen 1 is the most basic, nitrogen 2 next, and it is the least basic. This nitrogen is least basic, and this nitrogen is most basic. So how to write the answer? See, in CONH2, mention the 3. This is amide group. Due to resonance, in amide group, due to resonance, the density of lone pair of electron decreases. So N3 is the least basic, and in N1 there is no such electron withdrawing group. That's why it is the most basic, while NH2, that is 1, is the most basic. So the decreasing order of basicity is, the decreasing order of basicity is the decreasing order of basicity. Nitrogen 1 greater than nitrogen 2 greater than nitrogen 3. Clear? I think you understand it. Once again, this nitrogen is attached to pi bond. Double or triple bondeds are called pi bonds. Due to resonance, as oxygen is more electronegativity, oxygen has always a tendency to attract the pi bond towards it. That's why the nitrogen becomes positive charge, so density of electron on nitrogen decreases. So it's the least basic. If we consider it, it can undergo resonance. But here it has electron donating nature, so it pushes electrons, so it increases the electron density. That's why this nitrogen is more basic than this nitrogen. If we compare with it, actually this is electron donating nature, okay, some extent, while comparing. So this nitrogen is not attached to any electron withdrawing group, so it is the most basic. Very important questions, okay, this is very important for entrance also. Now, next question. I think you have enjoyed my teaching. If you have any problem, write me, okay. Now next topic, this is the last part of basicity of amines. See the, now if we say a question, arrange in decreasing order of basicity. The last question, okay, last question in amines. There are many questions can be there, so in my entrance classes I will discuss it, okay, later on. Now arrange in decreasing order of basicity. NH2 CN NH2 CH3 NH2 OCH3. Now tell me which is highest basic. Whenever there is any substituent in benzene, now methoxy group, any alkoxy group when attached to benzene donates by inductive effect, that is +I effect, as well as by resonance effect. As oxygen has lone pair of electrons, so by resonance effect also it by resonance effect. This is a methyl group. Methyl group has electron donating natures. It donates the electron. It only donates the electron by inductive effect. Inductive effect. Electron donating and withdrawing natures called inductive effect. If any atom or group donates electron, so it loses electron. So it has positive inductive effect, that is +I. If any atom and group withdraw electrons, so it gains electron cloud, so it's negative. Cyano group, as it has triple bond, if you draw the structure of cyano group, listen, if you draw the structure of cyano group, it has triple bond. So any atom attached to benzene contains multiple bonds, double or triple, then it has always electron withdrawing nature. Now say number 1, number 2 and it's number 3, I denote it, okay. Now so it is the least basic. It is the least basic due to the presence of electron withdrawing groups. Electron withdrawing group. This has electron withdrawing natures. It has electron withdrawing nature -I. With electron withdrawing group, okay. Withdrawing group -I. This is the most basic because it donates electron by both positive inductive effect as well as positive resonance effect. It has no resonance because, okay, only certain extents of hyperconjugation neglected. So it is the most basic. It is the most basic. Now, so the decreasing order of basicity, the decreasing order of basicity 3 greater than 2 greater than 1. Clear? Now, the final topic, that's called Ortho Effect. Okay, only I will take hardly 5 to 10 minutes. Okay, now listen. Ortho Effect. Ortho Effect. What is Ortho Effect? Actually, it is the part of entrance. Listen now. Just remember it. If any aromatic amine contains electron donating or electron withdrawing group, if any aromatic amine contains electron donating or electron withdrawing group at the ortho position, the basicity becomes least. So this is ortho effect. Listen, if last topics, okay, if any electron donating group or electron withdrawing group is present in aromatic, you know that aromatic means having benzene ring, aromatic amine, say it is aniline, say aniline contains electron donating group or electron withdrawing group, the basicity becomes least compared to meta and para positions. So understand one question and you understand clearly. So remember it, in any aromatic amine, you know that whenever nitrogen of amino group is directly attached to benzene called aromatic, contains electron donating group or withdrawing, the basicity becomes least, though you know that presence of electron donating group increases the basicity. So see the question, this is called ortho effect. Okay, this is last topics, please stay tuned, known as ortho effect. Please don't leave. Okay, this is a very important question, especially who are willing to sit in entrance, either JEE Mains or NEET. This is a very important question of ortho effect. Now, actually this type of question I have seen rarely in board, okay, but this type of question I have seen frequently in entrance. So please stay only 5 minutes. Listen, question, arrange in decreasing order of basicity. This is aniline. See, I insert one CH3 group here. This is aniline. Say one CH3, and this is aniline. Say I take one CH3. Its ortho position, its meta position, its para position. You know that methyl group has only electron donating nature, that is +I effect. +I, it has only electron donating nature, +I, positive inductive effect. Electron donating groups are called positive inductive group. It has also +I. This is denoted by 1, this is 2, and it is 3, say. Now, can you guess which is the most basic? Very easy. Anyone? Yes, correct. It is the most basic. Why? Because methyl group has electron donating nature and it is closer to amino group. So it donates electron. You know that the extent of electron donating power increases with the distance. Lesser the distance between the, say, its electron donating group, okay, and attached to the amine. Lesser the distance, more will be the power. If the distance increases, the strength of inductive effect decreases. If the distance increases, the strength of inductive effect decreases. So, yes, correct. As it is very closer to amino group, so it is the most basic. So, the basicity order is, so the decreasing order of basicity on the basis of electron donating power of methyl group 1 greater than, you know that inductive effect decreases with increase in distance. So it is closer, it is far. So 2 greater than 3. Correct? Am I correct? Anyone? This is wrong. Not. This is wrong. So I have just discussed that ortho effect, any aromatic primary amine, whether contains electron donating or withdrawing group, at the ortho position it's the least basic. So remember it is the least basic due to ortho effect. So remember it, whether the presence of electron donating or withdrawing at the ortho position of aromatic amine, benzene means aromatic, least basic. So the highest basic is between the two, anyone? Only inductive effect, and inductive effect decreases with increase in distance. So it is closer, so it is the highest basic. So the correct answer is 2 greater than 3 and greater than 1. Understand? Very important questions. Actually, this type of question I have not seen in board exam, but this is the very important question for entrance. Here, so remember is ortho effect. Now, dear students, my next topics will be on the acidity of carboxylic acids. It is also in your term 2 syllabus, okay? Please watch my next YouTube page. I think I can try my best to understand you. Okay?